Today we are going to start about quadratic relationships. Just to remind you that the real life application of parabolas, you can see different type of movies on YouTube. I encourage you to go and watch some of these movies, which shows you how these relationships are being used in real life. The first thing that we are going to cover today is the type of relationships. The first one, as you remember from grade 9, we have a linear type of relationships. In this relationships, if you plot the values of x and y, you get either an exact line like this graph, or you get a relationship which has a linear pattern like this one. Although the points are not all of them on the line, but you can easily see the pattern of the points, which shows a linear relationship. We now go and talk about relationships that do not represent a linear relationship. These are what we call nonlinear relationships, and they are best described by a curve. If you look at this curve, you can see that this graph doesn't look like a line, but a curve. Or this one also is best described by a curve which is not linear. That's why we call it nonlinear. Now we are going to talk about table of values and two new terms. The first one is first differences. If you remember from grade 9, we define the first difference as the difference between consecutive y values. This means that if I have a table of values of x and y, and I have different values of y, if I find the difference between these two and then write it here, then the difference between these two, write it here, the difference between these two, write it here, this is what we call the first differences. We now define a new term called second differences. The second differences is the difference between consecutive first differences now. So to find the second differences, you have to find the first differences, then you find the difference between the first differences. This is called the second differences. You may ask why we need the second differences. Is that based on the second difference and the first difference, I can define the relationship without even graphing. Just by looking at the table of values and first differences, second differences, I can tell you if this is a linear relation or a nonlinear relationship. Now, in a really linear relationship, if you look at the first differences, like in this example, 3 minus 2 is 1, 4 minus 3 is 1, 5 minus 4 is 1, and 6 minus 5 is 1. This is what you learned in grade 9. Since all the first differences are equal, the same number, which is 1 here in this case, we call this a linear relationship. And a linear relationship has an equation of the form y equal mx plus b, where m is the slope and b is the y-intercept. This we knew it from grade 9. Now, in a nonlinear relationship, the first one we call a quadratic relationship, is when the second differences are equal. Remember, when the first differences are equal, it's linear. If they are not equal, it is non-linear. Now, we are defining a new term when the second differences are equal. If you look at this example, 3 minus 2 is 1, 6 minus 3 is 3, 11 minus 6 is 5, and 18 minus 11 is 7. You can easily see that these first differences are not equal, so we know that the relationship is non-linear. Now, if you continue the second difference, 3 minus 1 is 2, 5 minus 3 is 2, 7 minus 5 is also 2. But the interesting part is the second differences are now equal. So, since the first differences are not equal, this is non-linear. Since the second differences are equal, we call it a quadratic relationship. Now, just to remind you that as a bonus, we said that if you can come up with a video covering the whole unit of quadratic, this is going to be a bonus mark toward your final unit mark. Now let's go and do some examples here. The first example says, given the following table of values, first plot this table of value. So let's go ahead and plot this table of values. When x is negative 2, y is negative 12. This is going to be off the chart, so I'm not going to plot this point. The next one is negative 1 and negative 7. So if x is negative 1, then y is negative 7. So negative 1 and negative 7 is going to be this point. Oops, that's a mistake here. The point is going to be negative 1 and negative 7, which is going to be this point. The next point is 0 and negative 2. So when x is 0, y is negative 2, which is this point. The next one is 1 and 3. So when x is 1, y is 3 is this point. When x is 2, y is 8. When x is 2, y is 8. We can easily see from the graph that this represents a linear relation because I can fit a perfect line going through all the points. The next part of the question says complete first and second differences. So to complete the first and second differences, I'm just going to find the difference between consecutive y values. So here the first one is going to be negative 7 minus 12, which is going to be negative 7 plus 12, which is going to give me 5. The next one is negative 2 minus 7, which is negative 2 plus 7, which is 5. The next one is 3 minus 2, which is 3 plus 2, which is 5. And the last one is 8 minus 3, which is going to be 5. If you look at all these first differences, they are all equal, so this is a linear relationship. I do not need to go to second difference because it's obvious that 5 minus 5 is going to be 0, 5 minus 5 is equal to be 0, 5 minus 5 is equal to 0. Since it's linear, we know that the first differences are equal, so the second difference is obviously going to be 0. And the last part of the equation says decide if it is linear or non-linear. We know that this is going to be linear because the first differences are equal. Now we are going to do the second example. The second example says that you have the following table of values plotted as the previous example. So I'm going to plot this one. The first one says when x is negative 2, y is 3, so it's going to be a point which is going to be given here. When x is negative 1, y is negative 3. When x is negative 1, y is negative 3, so it's going to be a point here. When x is 0, y is negative 5. When x is 0, y is negative 5, so it's going to be somewhere around here. When x is 1, y is negative 3, which is going to be here. When x is 2, y is 3, which is going to be here. First, notice that this is not a linear relation because a line doesn't fit through these points. So it's a non-linear relationship. Complete the first and second differences. So as usual, I'm going to find the difference between consecutive y values. So the first one is going to be negative 3 minus 3, which is negative 6. Then negative 5 minus 3, which is negative 5 plus 3, which is negative 2. Then it's going to be negative 3 minus 5, which is negative 3 plus 5, which is 2. And the last one is 3 minus 3, which is 3 plus 3, which is equal to 6. You can see that the first differences are not equal, so this is not linear. Exactly what we got from graphing. Now let's continue with the second difference. So here I'm going to say negative 2 minus 6. This is going to be negative 2 plus 6, which is going to be 4. The next one is going to be 2 minus 2, which is going to be 4. The next one is going to be 6 minus 2, which is going to be 4. If you look at the second differences, you can see that all of them are equal. Since the second differences are equal, then we can easily say that this is a quadratic relationship. And the last part says decide if it's linear or non-linear, and you can see this is not linear. Now, before we finish off with this example, if you look at the graph, you can see that this represents a quadratic relation. If you try to connect these to these 5 points, you get a graph which looks like a parabola, which you will learn later on. That's the name of the graph of a quadratic equation, a parabola.